Welcome everybody. My name is Chris Reardon and I am the Chief Technology Officer at Raventech. Thank you for joining us today as we dive into Raven Vision and its transformational approach toward Zero Trust. Our mission today is twofold. One, to show you how Raven Vision bolsters your current technology investments while aiding you in your Zero Trust journey. And two, to highlight how by integrating data from security, infrastructure, operations, and network, our customers are able to create what we call observability centers of excellence. This greatly enhances visibility and notably cuts operational costs by optimizing prediction, prevention, and response to incidents. Thank you for your time. Let's go ahead and get started. So a little bit about Raventech and who we are. We are an IT small business systems integrator. We are both a veteran and Native American-owned business. Our goal is to provide small company agility with big company stability. So our teams apply our industry expertise, understanding both the clients and business needs, and delivering the right solutions at the right time. When we dive into where our expertise really lies, and as we start moving down this journey that we're taking together today, we want to highlight kind of where Raventech has been, what we've grown up in, where our expertise is, and it really relies and lies in all of these domains. So enterprise visibility and performance, enterprise infrastructure, cybersecurity solutions, and data modernization and analytics. In our prior history, we've moved as a company over 14 federal data centers, whether that was migrating to the cloud, completely lift and shifting from a physical environment in one data center location across the country to a new data center location, having to shut that down on a Friday night and have it back up and running Monday morning. Well, that takes a lot of data, and we realized we need data not only to understand how things connect and what they're dependent upon, but also to understand and benchmark performance. How do we know that things are secure? How do we know things are performing the way they're supposed to before and then after the move? And then how can we hand that to our customers for the longer term operational sustainment of their environment? What we're really here today to discuss is how Raven Vision is able to take Zero Trust and approach it in a new way. And not necessarily anything too unique, but the reality is, what is Zero Trust? It's just a framework, right? But it requires all resources in your architecture. It challenges that old idea of trust within your network. No longer because I'm on X VPN or X network that I'm allowed to access Y resources. I need to be continuously verified, and I need to know that that access needs to be there for me to do my job. I need to understand, and my systems need to understand, that my role has not changed, that my activities haven't changed, that my behavior hasn't changed, and it's constantly validating that I should be doing what I am doing in my environment. It becomes a little bit more difficult as we move down into the continuous verification, upscaling authentication, all of these next steps that we have to do as we go towards the Zero Trust journey, but there's so many more granular things that we need as a foundation to start building our Zero Trust roadmaps. One, microsegmentation. We talk about physically defined perimeters no longer being as important as that software-defined perimeter. Defense in depth, some of the old legacy models around Zero Trust or around IT security, they still play a role. You're still going to have physical security. A lot of the tools that you're going to use for Zero Trust are already in place. A lot of these policy enforcement points and policy decision points might be your legacy or your existing systems, whether it be a firewall or an IDS. Any of those tools are going to be play a part in this. But the microsegmentation piece really allows you to get down into granular flows. You're actually tracking and analyzing every single transaction in a network. How do I know that I'm supposed to talk 443 to an individual server at that server level? Am I allowed to actually access that? Do I have to have 50,000 networks, or can I have one flat network where those rules are so granular and dynamic, I now know the baseline system behavior and the policies that need to be in place to enforce that behavior having to go. It really focuses heavily on identity. So really a strong identity focus, identity verification, validation, ensuring that you have identity proofing in that environment. But the key to all of Zero Trust is it's data-centric, right? We need to protect our critical assets, we need to protect our data, and we need to constantly be tracking those evolving threats. But how do we do all this and still stay productive, right? It's a need for balance. So Zero Trust requires real-time data from both security and operational systems. This data is coming in at high velocity and high volumes, but it's essential to ensure a dynamic balance between security and the robustness of your security posture and operational productivity and efficiency. So what is the reality around zero trust? So one, it's definitely not just a single turnkey solution. It represents a different approach to security engineering and architecture as a whole. And it involves some new technology. You're going to see new vendors out there that say they do zero trust or they attack this pillar or that pillar. But the reality is it leverages a lot of what you've already invested in within your IT environment or your IT ecosystem. The key here is observability is starting to now allow us under this guise of zero trust to span IT silos. So these data silos that we create by having multiple tools, different operational teams, different security teams. And what that does is it enables us to use that data to create dynamic zero trust policies, allow those decisions to be made with real-time data that's powered by both ML and AI in a very easy to digest and understandable fashion to the end user and to the systems administrators. So let's talk a little bit about these data silos. So what data is missing? So we asked about 275 federal employees just how many elevated privilege groups they had and accounts in their organization or their agency, how quickly they could identify those elevated accounts by egress and ingress, and on average, how long it takes them to track lateral movement. And as you can see, there is a lot of unknown. So where does that unknown come from? Why do they have that? What is missing from that data set that they're unable to tell us? Oftentimes what we hear is, I have that information, but I'm going to have to get back to you. So, but why is that? Is the data missing? Are they not allowed to have it? Did they not just want to share it because, they're doing a federal survey that we conducted online? They didn't want to divulge that information. All plausible explanations. However, we then asked this follow-up question. I found the responses very interesting and enlightening, and it goes to a deeper concept within IT and what we're finding across many of our customers, both from a federal, commercial, and state and local environment. So how many cloud-based security tools such as EDR, EPP, and CASB does your agency utilize? And the way we calculated this was taking all of those agents or all those responses and putting them into their individual agencies. So I might have 4 or 5 people that responded from an agency. Well, which tools did they say they had, or how many tools did they say they had? And what we found was 55% used 6 or more tools for just 3 functions. 23% of that 55 used over 20 individual tools for those 3 core cloud-based and endpoint-based functions. So the problem is cloud has introduced a lot of complexity. Monitoring and troubleshooting has gotten more difficult. You have to find the right person at the right time to solve that right problem. And what we're finding is a lot of this data is being maintained in these data silos. It prevents that data intelligence from being applied across your entire data set. It reduces what we call the concept of cardinality. We're not able to analyze and look at data from all sides, and the second you don't have enough data, you're not making the right decisions, and all of a sudden that availability end of that CIA triad starts falling off. Users start complaining. They can't access their work. They're not able to do what they need to do. So where does this data really come from? So let's talk about traditionally siloed IT data sets. When we really look at this, all IT organizations use different tools for different functions. We know this. Everybody has their domain, their area that they use various functional tools for, or various IT, whether it's a testing tool or a DevOps tool or a monitoring tool, MPM, APM. When we look at all these data sets and we tie them to zero trust and what zero trust needs, right? So from a zero trust perspective, I need data from devices, from applications, from network, from users. I need to rope in analytics and I need to build out automation. Well, what are some of those core data sets that I need for this? Well, I have security incident event management. I have continuous authorization and monitoring data. I have AI and ML behavioral data. That's both machine and human behavioral data, and we'll talk about that in a little bit. Your internal and external threat intelligence feeds. An overlap between your identity and access management, your IT service management, your asset management, your network performance management, application performance management, your cloud performance, cost, and security, and more, a lot more data is coming from that cloud performance, cost, and security. So visibility into one of these is great, but complete observability into all of this enterprise IT data is what's needed to make those policy decisions in real time, in coordination, and in line with following a zero trust framework. Obviously, this is just not limited to these core data sets. There's going to be other data out there that we can use to make these decisions, but if you really look at what is data, where does it come from, our belief as a whole is that one, all data is security related. You're only able to see once you know what you're looking for. So you can't really necessarily know that, hey, I'm missing this piece of data or I don't have this data because you didn't even know to look for it, right? So you have to know what you're looking for. And then you also have to understand what you're not looking for and how that's going to play into your overall data strategy and how you're going to make decisions and adapt those in real time. Zero trust, as a result, then, is a byproduct of complete observability. Most people don't have a compliance or reporting problem. They have that data problem. And that data really speaks and tells that story. It talks to the outcomes that you're going to be able to achieve within your organization. And the reality is we hear a lot about resilience and functional availability and all these other key buzzword terms out there. But the reality is resilience is only known once pressure is applied. I can't know if my system is resilient until I'm testing it, and I'm constantly testing it. So Raven Vision, what we look to do with Raven Vision is leverage real-time data aggregation to empower your observability centers of excellence. We deliver visible integration of security infrastructure, operations, and network data to inform zero trust architecture. So one of the key things with Raven Vision is, one, it's an impartial technology integration. We apply ML and AI for automation and putting yourself in a more proactive posture. We transition to service solutions for complete end-to-end observability. So we transition our service over to you to allow you to have complete observability in your environment. Our goal is to include all IT domains, including security, operations, DevSecOps, you name it. We want to include everybody and their data. We don't want to force them to be together, work together by meetings. We want to allow them to work naturally through that data. We want to maximize all of your existing investments, and we want to meet all of those compliance and mandate goals. That is our ultimate driver behind what we're doing with both federal and commercial customers today, is actually meeting those goals. And the only way to really do that is to completely integrate all of this data into a single context observability platform. So a little bit of level setting around what Raven Vision is. It is a service implemented methodology for zero trust. So one, from a people perspective, we have subject matter experts that are tailored to match most of the common technologies and some of the best of breed technologies that are out there in the environment today. So we provide services for those, and we provide them across all of those domains. Our key and our focus has been on full stack engineering from day one as a company, and that allows us to actually understand and know what those tools can do and what capabilities we can get out of them. From a technology perspective, we are not a product. We have very customized APIs that we have built that we can drop in place day one. For multiple tools, we're able to actually integrate various systems in an efficient manner that allows you to see all of that data and correlate that data across the various data sets, as well as work together a little bit more seamlessly from a day zero, day one operations. But we do not sell that. We do not license it. We don't do anything with it. We use that as part of our tool to deliver our service. And I will take a little bit of time here later in the day or later in this presentation. I'll show you a quick demo of how some of that data ties together and what that looks like. The process that we follow is our services process for Raven Vision. So one, again, maximizing those existing investments that you've already made to meet your compliance and mandate goals, integrating machine learning and artificial intelligence and automation to create a proactive posture. What does that mean? Well, let's back up a little bit. So if I am pushing 5,000 patches to an environment, the next day I have 1,000 users that are offline. Well, how am I going to troubleshoot that? Well, typically in a lot of IT organizations, you're going to call your help desk. You're going to get a lot of calls to your help desk. You're going to call your end user support team. You're going to call your patch team. You're going to call your security team. You're going to call maybe an application team. All of those teams are going to get together and they're going to try to figure out what happened. Why did this happen? Where did it come from? They're going to work and correlate across an entire day, and they're going to find out that, hey, those 1,000 users, just so happens they didn't get the BIOS update that they were required to have that allows that patch were crashing. So now I've got 1,000 users offline. How do I prevent that? How do I use ML and rope in AI to make a decision at a certain confidence score that prevents that from happening? Well, as I'm pushing that patch, when I look and I analyze after 10 failures or 10 checks from that patch and I see those failures, I'm now going to correlate those. I'm going to understand from that correlation that the root and most common issue associated to those 10 users is that BIOS. And the confidence score is going to be high enough that the AI then is going to kick in and say, I am going to go pre-check every single one of these systems for that BIOS version. If it has that, I am not going to push that patch. I'm going to put them into an isolated or quarantined or maybe even higher security posture because they don't have a critical patch and they're missing a BIOS update that was required. But I'm going to allow them to be online. So now the next day, without any human interaction, I've got 10 users with a resolution knowing that I need to update their BIOS and get them back online. I've got 990 users that need to follow an updated process. I need to push the BIOS update, I need to force that update, and then I need to push the patch. So instead of having 1,000 users offline, multiple VIPs, all of those people that are concerned and not able to work and be productive, I only have 10. I can work with those 10. I can solve them and tackle that pretty quickly through automation. If I can't get it through automation, it's a lot easier to handle 10 people than 1,000. So as we start working through these use cases, that's what we focus on, is using the data to drive use cases that mean something, that provide outcomes to the customer. So when we approach Raven Vision, we look at, this is a zero trust capability model that was developed by Jerry Karen, who is the CIO of ITA. And he laid out the core pillars and core capabilities within zero trust. And he allowed us to actually take this model and turn it into our own. I've worked with him on the Zero Trust Council. We're actually part of the ATARC lab environment, and we're standing up a Zero Trust lab that incorporates all of these capabilities. However, taking this model and putting it into more of a data-centric flow, how does that work? So what we did is we came up with our Raven Vision data intelligence model. And this is how we benchmark all IT systems that are currently existing in the environment today, what capabilities they have, and we marry them against this model to give you kind of a maturity score for your zero trust journey. So instead of taking those individual silos of device and endpoint, network and environment, application and workload, and user, and keeping them separate, we put them into a common data lake. For us, we rely heavily on a product that most organizations already have, that being Splunk. The Splunk Enterprise platform and the cloud platform has allowed us to aggregate this data, do all of our segmentation, our dynamic massing, doing automated tagging with AI and ML, both on ingest and at rest. We're able to do data rights management to ensure the right people have access to the right data to see what they need. All of our classification, our metadata management, now of our encryption, as well as our DLP. So the key here is now I have all of this data from device and endpoint, network and environment, application workload, and user in one place. So when I go to troubleshoot an incident that might be related to network, how do I know that network incident is not related to a security vulnerability or an exploit that's happening in my environment? Well, if I have all of the data in the same place and all teams are working off that data, you're more quickly able to get to that root cause and you're able to solve that problem. So this is where we pull in that visibility and analytics. Now, everything is not necessarily going to be done in your data platform or in Splunk. You might still leverage your existing same data set, that authoritative data location that's actually doing the analysis and pushing those analytics. So as I rope in internal and external threat intelligence feeds, as I start doing visibility analytics and feeding that data back in to inform the data lake, now I have the ability to do true machine learning. I can do advanced threat protection. I can start getting dynamic risk evaluation and scoring for those connections that need to be continuously verified, right? So if I'm coming in and I have a risk score because I'm in Asia next week and it's high and they're not letting me log in because they don't have anything that says I'm allowed to be working in Asia, well, how do I prevent that? Well, now to lower that risk score, if I have the right data, if I have a system, an ITSM or ticketing where my ISO has approved me in an authorized work location in Asia that week, I don't have to come back and do that. I don't have to do that manually and call in and be unproductive for 2-3 hours while I try to get a hold of somebody in the United States. What I'm able to do is log in, and my system is able to see that I am authorized to work in Asia that week, and I have a fully approved and vetted travel plan. So now I'm being productive. I don't have to bother the help desk. I don't set off a security alert. All of that data was brought into the same place. And really, what are we talking about? We're talking about travel data. It's not even IT data. It's travel data. Hey, I'm authorized to travel to this location. My ISO has approved it. All of that's in there. It's just a very easy concept and use case to just explain kind of how you would actually leverage a lot more data than just IT metrics. The biggest piece here is discovery and baselining. So one of the key tenets, in my view, around zero trust is actually understanding the baseline behavior and patterns within your system and how it performs. What does that mean? Think of it as like a signature. So my system behaves on a normal basis at 50% memory. It's got 25% CPU. It uses X amount of storage per day. It's growing at about this rate, so I'm going to see a capacity analysis, and it talks across these ports. By discovering and baselining that system behavior, that signature, if you will, I can now start detecting anomalies. I can start putting that ML in place to see, hey, I spike at this time of month, or I see this pattern happening when I have an active exploit, or I see this process or this rogue DLL that's been running on 5 or 6 systems after I have an incident that happened where somebody actually had a vulnerability that was exploited and they inserted malware into my system. All of those things are able to be drawn out because you now understand how your system is supposed to behave. You don't have to look at it every day, analyze it every day. You allow the ML to do it for you. Once we have that, now we can start finding things that are happening in the environment frequently. Frequent problems that are going on in the environment that we can target for automation. How do I automate deployments? How do I automate patch pushes? How do I automate blue screen of death resolution, right? All of those pieces that we can start tackling one at a time to take and lessen the burden on those service desk people. How can we enable tier 0 to start working for the end user? How do we actually enable automation and incident response? How do we use artificial intelligence appropriately and have high confidence scores that we don't necessarily need a human in the loop? In the federal government and a lot of our government customers in the public sector, they want the human in the loop. They want to be able to say, okay, yes, that's a high confidence score, but I'm still going to click the button to execute. And that's fine. The idea here is actually having that button to click and not having to go through and do the entire resolution process. Look at what is actually happening in the environment and understanding that my system found these problems. I didn't have to go and analyze troves of data. I was able to extract and pull those insights out that mean something to me that's going to drive an outcome, right? So now I have automated incident response. I've got API standards because all my data is communicating. Those APIs that we talked about that we've been developing with all of our technology partners play a key role in this. Actually being able to openly communicate and have data flow that is normalized and common across the IT landscape. You know, how do I change IP address to IP ADDR, et cetera, and then correlate that same number, that same address across 3 different systems. From here, what you see is we've pulled all this data up. We have all these teams now working together from a data perspective, and then from the top down, what do you get as an executive or as an IT leader? You're able to start seeing your threat scores be more accurate. You're able to do accurate risk scoring. You're able to do target valuation. You're able to do triage priority more quickly and rapidly. And as you mature in this model, as we come in and benchmark and we look at some of the gaps and the overlaps and the capabilities that you may or may not have, you're going to be able to start seeing compliance scores go up. You're going to be able to start seeing all of those things that you're required to do from a mandate and a compliance perspective start becoming reality and start becoming more real and based in metrics and numbers and not based in just thought. So you're able to put empirical data behind, hey, this is how I'm increasing my compliance score. I went out and I found out my patch and vulnerability management system wasn't fully integrated. So we brought in Raven Vision and we integrated the full patch and vulnerability management system. We were actually able to put in all the capabilities and bring those tool sets to bear. That's what we do. When we come in, we're looking at each one of these capabilities, looking at all of the tools that you have currently invested in, and we're analyzing those across each other, understanding the gaps and overlaps in those. So a couple of principles that create a foundation of success for us within Raven Vision. One, we understand every organization is unique. Our biggest goal is to find a champion to coach their staff and peers through innovative organizational change, not death by meetings, not constantly sitting in a boardroom or in a conference room and talking about how we work together, actually using that data to drive that organic change from an organizational level. Organizational change is one of the hardest things to do, especially when we talk about data sharing agreements, data rights management. People are sensitive to that. We understand that, and the key is to have a champion and a top level, either executive or a sponsor, that's able to go in there and say, this is what we need to do and this is why. From a process perspective, we want to include everybody. So all IT operations, the application team, your performance teams, your security teams into a single project and challenge and assist them to getting to an as-a-service IT organization. It's the ultimate goal for every IT organization. They want to be as a service, right? They want to operate as a service. They don't want to be you know, the IT department that has to do everything. They want to be the service that provides the capabilities and the tools needed to either execute a mission or execute the business that you're working towards. So from a technology perspective, one, we understand that technology is expensive. Our priority is evaluating and getting the most out of what you've already invested in from both a staff and an IT perspective. We want to innovate observable data intelligence with AI and ML. So all of your monitoring, troubleshooting, and automation functions, we want to start leveraging ML and then putting some AI behind it to make decisions about how we can predict outages, how we can stop things from happening. Taking an example of the VA, where they were able to put in ML and actually predict telehealth service degradation 15 minutes in advance so they could spin up additional resources. That was amazing. Those types of scenarios are the things that we look to put in ML. We're not trying to boil the ocean. We can't do everything at once. The key is critical outcome-based use cases that we focus on. And then we provide our experts to really integrate that data, build that observability platform through your data consolidation. In any engagement, when we first come in as a service from a Raven Vision perspective, one, we're going to follow our data value chain process. And it's a CI/CD process to gain intelligence from all of your existing data sources. So we look to rationalize and completely understand all of your tools to get to marry those against the data intelligence model and see the gaps and overlaps in the data that you have. Work across all teams to make sure we're discovering all existing data sources. Where's the data coming from? Where don't you have data coming from? What type of data do we still need? And only the right data. We don't necessarily need to bring in all of the data. We need to bring in the right data to answer the right questions and solve the right or give you the right insights. And then we develop a observability roadmap to actually integrate those and schedule that out depending on the size of the environment. From a design perspective, we architect existing and new data source integrations to fill those gaps and eliminate any of those overlaps. We integrate those data flows into that observability data lake. In our case, we've been integrating it into the Splunk platform primarily. And then we transform that data into actionable reports. And this is the key. Just putting data in one location doesn't do anybody any good. It's the insights and the reports that we get out of those. By getting those insights and reports, we can start so we can use correlative analytics to identify data interaction impacts across teams, across those IT domains that currently or may still be in silos. How do we see an application developer all of a sudden start calling the network team and go, hey, I noticed a problem in the network? Or the network team going, hey, guess what? It's not the network. Your application is flooding my circuit with random erroneous data, right? So you're able to see those teams work together. And they don't necessarily have to be sitting in the same room, but they're working from the same data set. It's not about having 5,000 monitors up with 10 different tools on them. It's about having one common data set, one set of monitors, and all of that data being analyzed and correlated across it. By doing this, we incentivize process, right? We drive efficiency by reducing the mean time to detect and the mean time to respond, and it creates synergy within the organization. It educates and trains those individuals to be more full stack engineers, because that's really what we want to get to. We want to have that observability center of excellence where they understand impacts from a security perspective on operations, from an operations perspective on security, and how those all tie together. And what this allows us to do is encourage that team to use those to make data-driven decisions. How do we start using empirical data to drive decisions to be made? How do I know which systems or laptops or devices that I need to replace? Am I doing it just because of their age? Or am I actually looking at the performance of those devices and determining, hey, you know what? I might have 500 really old devices, but of those 500, maybe only 100 of those actually are having performance issues because they're heavier users, they're power users. So maybe I need to focus on replacing those first, and I might have that same condition on a newer version where I've got users that have a newer version laptop, but they also have performance degradation. Maybe they need a newest version laptop, or they need an upgrade in that capability or the capacity of that laptop. Again, those are the things that allow you to make those true data-driven decisions, that smart device refresh, true analytics, advanced threat hunting, all of those things that we can start incentivizing people to work together on and allow them more time then to focus on what's next. How do we modernize? How do we innovate? Our big focus here is getting as much of this into an automated flow as possible so that we're then able to start predicting use cases and finding repetitive incidents and processes. We're able to prevent and respond to apply data-driven zero trust policies, both from a SOAR and ops perspective, to prevent and respond, right? We want to be able to predict and prevent, that big prevent posture. And then we want to protect, obviously increasing proactive threat hunting, being able to analyze all data, all patterns, all behaviors, using that pattern analysis then to detect vectors, to detect indicators of compromise across the environment and scale those throughout, so that you're actually able to do that analysis and do it in an automated way that prevents your users or your admins from spending days and days and days analyzing data instead of solving problems and reducing incidents. What I like to say at the end of this slide every time is our ultimate goal is to get rid of that concept of mean time to innocence, right? So everybody's always, it's not me, it's you, and here's how I can prove it's not me. Well, how do we get rid of that concept? How do we actually start getting to a resolution? That's what we're trying to get to. So at the end of the day, our goal is to create that observability center of excellence, aggregate those data silos, build a collaborative IT organization that's focused on proactive security and end-to-end sustainment, provide AI and ML-driven team for monitoring and response, providing both continuous and dynamic enhancement of policy and process automation. That's a word, it's a mouthful, but the reality is what we're trying to do is actually enable that dynamic policy to be made with data. We want to be able to use the data to make those decisions. It doesn't have to be anecdotal anymore. It can be empirical, and we understand what that is. From a federal government perspective, because we're pulling in all this data, because we're aggregating it, a lot of it ties to M2131. So we're actually building a compliance metric or a model to start going towards M2131 compliance and building that roadmap out. We want to use that real-time data then to inform your ZTNA or Zero Trust Network Access solutions, your policy decision points and enforcement points with dynamic risk scoring, and securely inform those trust algorithms. Work with those other those other IT technologies that you're bringing in new, that might be the Zero Trust technology, and inform and educate the data that's in there to actually make those decisions in real time. So by doing this and creating those dynamic policies and enforcing it in an automated way, we're able to get that proactive data intelligence that truly allows you to be in line with NIST 800-207 as a whole. So with what we've done with Raven Vision, and as some folks may see in the demo later on, what do you want to see as an executive? What do you want to see as an organization from a high level? I want to see my infrastructure. I want to see my application. I want to see digital experience. I want to see log investigation, incident response. And I want to be able to pull that from all data sources. So while we feed everything into Splunk, it's not buy everything Splunk. It's actually feed the right data at the right time from the right sources to get the insights and outcomes you're looking to get from an organization, and then allowing yourself to automate those actions. How do I automate as much as possible? When we look at Zero Trust and we look at maturity models, and you look at even EL3 from a M2131 perspective, what are we doing? We're automating. Automation is something that a lot of people think, well, that's going to be automatic. Well, you still have to do a little bit of the work up front to get to that automated fashion. Whether you're using Ansible or ServiceNow or any of these other tools to run your playbooks, at the end of the day, you're writing Python script to get to an automated response. And when I do it once, I don't have to do it 500 times. And that's where we save money, and that's where we can start innovating and thinking about the next step. What's the future look like? How do we start going towards things like quantum and other areas versus constantly putting out fires? That is really what we're trying to do. That's what we're doing with Raven Vision as a service, and both working with Splunk and other teams to make that a reality within their customers. And we're hoping that we can start to make it a reality for you as well. So folks, before we wrap up, what I wanted to do is walk you through a little bit of our lab, where we've set this up, what we've done with it. This is wholly foundationed on some of the core technologies out there today that are focused on Zero Trust. Everything from Okta to Splunk to Zscaler. A lot of those technologies that we integrated together to create that full picture, that full integrated solution. So what does this look like? So the reality is, what I'm going to do if I'm going into a Zero Trust model or I have a Zero Trust solution, I'm going to log into my portal, my Okta portal, my identity portal, where all of my authentication is going through. I've got a back-end authentication that's coming in through Azure. I've got a number of other tools, but I'm really going to focus for the purpose of this on some of these Splunk capabilities in the Splunk tool set of where we actually aggregated and brought in that data. So when we look at the executive level from a Raven Vision perspective, as we go through here. I'm going to go down to, you can see all of the tools and the integrated technologies that we've brought in, all the different adapters and some of the APIs that are already part of and out of the box within Splunk, and some of those that we've custom developed for our customers that come within our Raven Vision app. This isn't necessarily something that you have to drop in or you have to use. We can actually rebuild this app based on the APIs and the dashboards that we built within it inside an organization. However, the application itself allows us to actually see and go into the executive level all the way down to the operational and the board. I've got data coming in from different EDR devices. I've got Tanium, I've got Tenable, I've got Tenable scans, I've got Sentinel-1 data that's coming in. I'm running event gens on the back end, and keep in mind this is a lab environment, so a lot of this is event gens. You'll notice patterns, they're supposed to be there. However, looking at a high level as an executive, I can go in here, I can see my ServiceNow, my ticket data, I can see all the requests that I have pending, I can see my vulnerabilities. High level CPU and memory utilization, yeah, that's great, but now I want to dive into it. I really want to understand, well, why is it trending up? What memory is actually causing me issues right now? So now right from that same dashboard, I'm able to go in and I'm able to see, hey, it looks like that memory is going up, but it's only on a particular host, and I can see that host is MySQL 02. So now I understand that MySQL 02 is having an issue. I can go into that search, I can analyze that search, or with what we've done, because we already understand that there's issues that need to be solved from a database perspective, well, we're going to go into our database overview. So I want to actually look at that MySQL 02, see what's going on with that database and see where it's coming from. And right here I can actually see, oh my goodness, it looks like somebody actually just changed employee info and changed a password, which is actually causing MySQL 02 system to spike its CPU load because it's constantly running queries that it doesn't have authentication or rights to do. So now I'm able to see that information, I'm able to log that information, I'm able to troubleshoot that from an operational perspective. And again, down below, as we start talking about ML and AI, we're actually able to forecast that CPU load. So we can actually see that, hey, if we don't address this, that CPU load on O2, right, it's spiking up and down, up and down, up and down. That's each time it successfully or unsuccessfully hits that query. So we're able to trend that in the future. MySQL 03, we can actually start seeing the expanded bands that are coming out. So this is actually the utilization forecast on when it's going to increase, when it's going to decrease. Same thing with MySQL 04. And again, these are all ML toolkit based predictions that we've made with the Splunk toolset within the Splunk enterprise environment. So that's IT operations. From an executive level then as well, I want to go back and I want to look at cost. I want to understand cost. I want to understand where my money is being put and what I'm spending it on. So now I'm going to pull in my budget. I'm going to see my revenue versus my cost. And in the federal government, I might see my budget versus my cost. I'm going to see my daily support cost, meaning my operational support cost, as well as licensing. I'm going to see my utilities, meaning if I'm working at a colo, something like an Equinix or those types of facilities, I'm able to import that data from their bill, and I'm able to actually see what that cost is from a utility perspective or a square footage perspective. And then obviously my cloud perspective. I really want to look at the cloud and understand what that is from a cost perspective by the month and how long it's been trending at that cost level. Here I can set a budget. I can understand what my budget is, where those are at, and what I'm actually trending against for my budget. If I want to go into individual resource costs, I can look at each endpoint. I can understand, and what we've built in this model is something where we can drop in and say, from a Tanium perspective, it shows $104 down here for Tanium. Well, what does that mean? Well, realistically, maybe Tanium was only $50, or that's what I was sold, but I've only deployed 2,000 or 2,500 of 5,000. So I bought 5,000, I only deployed 2,500. Well, my actual realized cost then is double what I thought I'm paying because I'm not getting the value out of what I'm paying for it. So again, the focus here is actually driving those value outcomes, seeing things like this and being able to say, hey, why haven't we deployed that to every system? Should we be deploying that to every system? I think those are some of the key metrics that we would want to trace and nail down. From a other areas, IT operations perspective, I can go into VPN. I can look at all of my VPN overview, my connections. I can look at my actual performance of my top users, my activity, how long they've been connected, the login results that they've been logging in with. I can look at all of my endpoint security. I can pull in things like Guardicore, which is a microsegmentation solution I'm actually looking at malware. I'm able to see malware overview over time. I'm able to actually trend activities now from an ML perspective. I'm looking at malware prediction over time. Now, obviously, we're running event gen, so it's pretty easy to predict when we're going to get malware because we actually trigger it on purpose. But again, these are the types of things that we're able to pull out. And instead of pulling it from every single application within Splunk, right? So, I mean, typically, what would I do here? Well, Guardicore or SentinelOne or even Zscaler data, I would go into that individual app. I'm going to have to pull up that app. I'm going to have to look at Guardicore and go through the Guardicore app or click back and forth. What we're doing is we're pulling all of that data in. We're pulling all of that data into our app so that we're able to just view that in one context and without the products being kind of up front and center, right? I get this same data from the application that we're running or the agnostic Raven Vision component versus going into 10 different apps. Even though it's still in a single tool, I'm still able to navigate around. It's pretty intuitive. A lot of people get confused with Splunk. They've integrated a lot of new capabilities and features into their newer platforms, even natural language processing with AI for some of your SPLs or your searches that typically confuse a lot of folks and make it, back in the day, I had problems with customers that didn't want to necessarily use Splunk because they're like, I don't know how to do the search language. But the reality is, this is a lot easier to use. When you're looking at dashboards and you're looking to drive outcomes and you're looking to track metrics, just looking at a dashboard gives you a lot of information right out of the gate. So from there, we can go into looking at our tickets. So now I want to look at all of my active tickets. So I'm pulling in ServiceNow data, whether it's ServiceNow or Remedy or any other ITSM system. But as Raventech, as a Splunk and a ServiceNow managed service provider, we obviously go with ServiceNow. So now I'm pulling in all of my active tickets. I'm showing my closers. I'm showing my assignments. I'm understanding my division of what actually is happening out there. I understand the criticality of the tickets that are coming in. I can drill down by incident. I can look at the assigned groups that they're going out to. I can look at the open close status, all of the statuses associated. From that same perspective, I can go in now and I can look at my change requests, what's on the schedule, what's coming up. All of those things that we're able to. So one of the other things we can look at is, from a compliance perspective, I want to look at my MITRE attack strategies that are being seen across the network. What is actually being seen in my network from an attack perspective, and then how am I defending against it? Do I have enough data or enough sources then to run the MITRE defend against, and what am I seeing and covering from those defense strategies perspective? So just a high level look at that. But when we look at network security, all the authentications, access control list, IDS, I'm actually able to see who's logging in from where, what they're doing, where they're coming in from, and I'm able to go into the investigations to the point where now I can start looking at, okay, traffic trends from a network perspective, antivirus trends, IDS activity, host event logs. I want to understand what's actually happening in these systems, but you know what? I want to understand by severity. Maybe I want to look at, critical only. So now I'm looking at critical severity. I'm coming down here. I'm seeing, obviously, I've got a lot of critical vulnerabilities. I have a number of host names and users that are logging in to different systems. I see I have policy violations, and I see process creation kicking off left and right across the board. So login, success, all of my host event logs that are coming across. And I can see down here, if I look up, I now see a spike in traffic activity. I see my IDS activity starting to go up, and I see my host event logs kicking off with successful failures or successful logins. Why is that happening? Well, it looks like I'm traversing across the environment. So a user, in this case, Regrina, or R. Grina, came in. She was actually using a IM messenger or file transfer service. That file transfer service now is showing, look at this, lo and behold, I've got a file that's going into my network. I used it from an IM perspective. I was able to download it. Now it's actually going laterally across my network. So now I'm getting access detected. I'm actually seeing probes go across the network. So now I can put in an automated playbook that resolves that. It puts that policy back in place, informs the user, blocks that file, and then restricts that from going across my network. So by pulling all of that data together, seeing spikes in traffic on the network, seeing spikes in IDS activity, rolling it down to my individual critical event, and then creating a SOAR playbook to resolve it. That's really what we're looking to go after from a zero trust perspective and from a data consolidation perspective, understanding everything from IT operations to service desk, network, end user, all the way down to an investigational technique. So that is the ultimate goal of what we're truly trying to do with Raven Vision, and some of the other pieces that we have inside of that, like from the Splunk ITSI perspective, just being able to look at service health, service analyzer, all from an infrastructure perspective. So we have the infrastructure pieces, we have the IT security pieces, we have the application pieces, all tied into a single consolidated observability platform that's easy to navigate and intuitive to the end user. Again, I want to take a little bit of time and thank you guys for spending the day with us and being here. And we look forward to talking to you a little bit later. Have a great day.